All right, here comes Jonas. Hello, everyone. We have one late arrival. Jonas will be here in just a second. Hey, Jonas.
Hey, everyone. Good evening.
Hey, it's good. We got nearly a full house. We need to get one more student. We'll actually be back to 5 live instead of 4 live. We're going to do some quick introductions. I'll have Dana introduce herself first, and then we'll all go around and introduce ourselves to Dana. And so Dana, just a little bit about your background, what your goals are, and what you're looking to get out of the class. Is that cool? And anything interesting you want to tell us about yourself?
Oh, hi, everyone. My name is Dana. I'm from New York. I met Eric, I'd say, about a year ago in a previous boot camp hosted by Amex. And I'm hoping to be more comfortable with software development by the end of this program. Fun fact about myself, I love cats. Yeah.
Good. Cat people are awesome. Excellent. All right. Alexandra, you want to introduce yourself?
Yeah, so it's nice to meet you, Dana. I'm Alexandra, and I'll just kind of repeat what I said before with our introductions.
Yeah.
I'm kind of looking to get into software engineering and hopefully someday, like way later down the road, get to where I can teach it. And fun fact about myself is I celebrate my half birthday.
Oh, that's right.
Yeah.
That's right. I like that. That's 2 presents a year.
Yeah.
Yep. Jonas?
Okay. My name is Jonas. I graduated on April. I'm from Ethiopia, Addis Ababa, located in East Africa. Fun fact is, I joined university at the age of 32. I graduated at 36. And
Yeah, you don't
now,
look 36. You're just lying. You're not 36. You're a lot younger than that. You look good for your age. I'll just say that.
Okay, thank you. And now I'm about to become full stack developer.
Yeah, very excited about
That's
that.
my goal. Yeah.
And you just finished your degree just a month or 2 ago, right?
Yes, on April.
On what? In April? Okay, good. Congratulations on it. It's awesome.
Thank you.
Yep. And Sudesh.
Hi, Dana. Welcome. My name is Sudesh. I'm based in the UK. I am trying to move from my long manufacturing career to the tech industry. This is why I'm doing software engineering. So the fun fact is, I have a dog and I do a lot of walking with dog. So
Excellent. You guys have had quite a heat wave this summer to go walking in, huh?
yes, yeah, we had, but it's okay now. It's getting cooler now.
Good.
Yeah.
I'm Eric Gross. I'm the instructor. Obviously, you know me, Dana. I guess the only fun fact. I lived in a teepee, like Indian teepee, American Indian, when I was 2 years old. And I lived in a giant house shaped like a wine barrel. And I lived in a Volkswagen van. And I lived in a geodesic dome, like the domes that they have at Disney World. Yeah, my parents were hippies. I lived in a lot of weird places. Oh, and I was just talking to my dad about this a couple months ago. Lived in a caboose, you know, the tail end of a train. And my whole life, I thought it was like a real caboose. And I'd always wondered, like, how did Dad get a caboose up in the middle of the redwoods? And we were down there a couple months ago, and I started talking about this. He says, Eric, it wasn't a caboose. It was just a trailer that some guy painted to look like a caboose, and you were 3 years old, so you didn't know the difference. So my whole life, I thought I lived in the tail end of a train. Nope. Oh yeah, and the last one, I lived under a bush in Golden Gate Park in San Francisco when I was 3 months old. I found that one out 2 years ago. Found out that my mom lived under a bush in the summer of 1969 in Golden Gate Park, San Francisco. So yeah, pretty normal upbringing, pretty normal. Yeah, not at all. Okay, so Dana's going to be obviously, picking up midstream here. We're towards actually like the latter part of the training where we're going to bring everything together to actual full stack applications and build a lot of projects together, and then move into like the job search process and how you get hired. She's doing some catch up on the videos and such, right? But also has been through a whole boot camp before and has some prior knowledge, just like Jonas does. Alexander, I know you've done some your own study and you work for Real Python. Everyone here has done some sort of study on their own. So I don't think Dana will have any problem catching up, but at various points, I've given her leave to just cut in and say, I'm not quite sure what that is, especially if it's something we covered earlier in the boot camp. And I may just step in, cover some stuff. Can't hurt to hear it over again. So anything anybody wants to talk about before we just jump into the material tonight? All right, we're gonna do a lot of hands-on coding tonight in SQL. First of all, just a quick status check. I want to find out how far through the W3 Schools MySQL tutorial people have gotten. Sudesh, where are you on that?
One second.
Like if you look on the left-hand side with all the different, how far down are you?
So I pass the order by where I did some exercises on insert.
Excellent.
I did not just following the same. I just jumped in and did some later ones as well.
Okay, good. Okay, excellent. And Jonas?
I've gone almost through lots of them. I almost finished it.
Let me share my screen actually. So the first portion is just about the language itself, MySQL, all the commands. And then there's how to work with databases, creating databases and tables and keys and everything. And then a few more additional data. How far down are you, Jonas?
Okay, I've gone almost all of it.
Okay,
all
good.
of it. Yeah.
Excellent. Okay, and Alexandra?
I'm at the insert select.
Okay, good. All right, excellent. Okay, good. So what we're going to do today is a lot of practical that will review stuff that most of you have gotten through, and then add on to it. And we're going to do that not in this tutorial, but in the Sequila database inside your MySQL installations. Okay. So let me pull up what I was looking at. Give me just a moment. Okay. All right. So let's do some quick reviews. I want everyone to code along with me. And if I go too fast, just tell me to stop, cut in and say, hold on, I need to catch up. I don't want to leave any of you behind on any of this. This class is for you folks. So I'm going to close all my windows here and just give myself a clean editor experience. I recommend you guys that do that as well, just so you don't have a bunch of busyness, but it's up to you. All right. So just some basics. And again, you never have to memorize syntax. It's the logic behind the syntax that you really want to pay attention to. So let's just do a simple select. So give yourself a new tab for building a query. And what is it that I recommend you have at the top of the query to make sure that you're targeting the right database?
Use.
Absolutely. So let's give ourselves a use Sequila, so there's no doubt which database we're going to operate against. And let's say in the actor table right here, I want to see just the first and last names of all entries in there. What would the syntax for that look like? Feel free to look it up if you need to. Sudesh, what do you think that syntax looks like to see the first name and last name of every row in this table?
Select from actor.
Select from?
Select from, 1 second.
Take whatever time you need.
Yeah, select from actor, first name, comma, last name.
Like that?
Yeah.
All right, let's see if that works. It doesn't. You have an error in your SQL syntax. Can anybody spot what's wrong?
So I think it's going to be select star from.
All right, let's try that. Like that. Let's run that. Well, that's closer, but I'm getting all of the columns, and all I want is the first name and the last name.
I think instead of star, you need the columns there, first name and last name.
Let's try that. Boom, there we go. So I often write it like this. The select, the table name that I'm selecting from, and the list of columns right in between. I like to write it that way, just for readability's sake. Obviously, it's not required. In fact, you can put it all in one line. And it runs. Now, there is a learning opportunity right here. So let's step back a little bit and go over again the idea that this database, this Tequila database, is being managed by a program we all have on our computers right now called MySQL Server. Now, that's not the program we're in. We're in MySQL Workbench. But this database and all the others that you see here, these are all being managed by this program that's running on our computers called MySQL Server, right? And it operates in a client-server relationship, as we've seen. Right now, the client is the MySQL Workbench program. We write our code right here. And when we click on this execute icon, this client, the MySQL Workbench program, takes this text and through the connection it already has to the MySQL Server program, sends this text to the MySQL Server program. The MySQL Server program says, oh, use Tequila. All right, I'll target this database and run these commands. Select first name and last name from actor, and it does that. And then it gets this result set right here, and it sends that back to the client called MySQL Workbench, which displays it for us in the result grid. So even though it happens really fast, you got to keep that in mind. Any questions about those concepts? Okay, now, with any situation where you are sending traffic over the wire, meaning using a network to send information from one computer to another, one of the primary concerns we all have as engineers is how do you make sure that you can have the request and response happen as fast as possible? Now, the sending of it happens pretty quick. MySQL Workbench can very rapidly take this text and send it. The execution of the query down in the database is pretty quick. We're not talking about either of those things, though. What we're actually talking about is the time it takes for this text to arrive to the server. Now, right now, the server's on my machine, so it's only going to take a few milliseconds at most. But that's not the situation we'll have in the real world. In the real world, your database server, the computer that's running MySQL server and that has all the databases on it, your database server will be some distant computer, and you have to send this text, these commands, over the wire to that server. One of the chief factors in how long it takes to get that traffic to a distant computer is how big is the data. And so every single time you send a carriage return, another carriage return, another carriage return, that's one piece of unnecessary content, unnecessary data. As we just saw, the SQL Server program doesn't need those things. They're there for readability's sake. So one thing that can happen behind the scenes is that we can take something that's formatted for readability, and the client behind the scenes will minimize the size of it before it sends it over the network to the server computer. We're going to see this concept come back again when we start doing our web development, which is the next sequence, next part of our training. We're going to take our JavaScript skills that we were practicing down on the server, and we're going to start to use those same JavaScript skills in the browser, in a client. And this concept I just talked about, where you take the code that is actually formatted for readability and you compact it by removing any unnecessary spaces and carriage returns and such, and only then send it, that is a key factor in making the web work faster. It also applies here. So I just wanted to show you that like I said, you can format it like this and it works just fine. Any questions about that concept I just covered? All right, let's go back to readability. That's more readable. All right, let's look at a different query. Excellent. So I'll talk about having this use Sequila thing here, but there's another way to guarantee that you're using the right database. And it brings in another new concept that we haven't covered so far in our training. And that's the concept of the fully qualified name for a thing. Now, rather than trying to explain it in abstract terms, I'm going to show you. Let's delete our use Sequila. And let's go over here to right before the actor table. And let's type Sequila and then dot. That is the fully qualified name for that table. And fully qualified, a qualification is sort of a restriction or an exemption, a caveat. It's a specification. And it leaves aside, it eliminates any possibility for ambiguity. Remember, the reason that we were even talking about putting use Sequila at the top is because we wanted to have no possibility of confusion on the part of the database server on which database you want to execute SQL against. Well, this does the same thing. You can also use it for giving column names. The format is the database, and inside that database, the table, and inside that table, the column. You're going to see variations on this syntax when you encounter SQL code in the real world. So I wanted you to at least have encountered it here in class. We're going to continue to use Sequila like that. So go ahead and revert your code to that. Now let's look at a couple other cool things you can do. There's additional ways to shape the data you get back from the database, to format it. What I like to do is to return a fake column. And what I mean by that is I'd like a column to be returned that doesn't actually exist in our database. I want the first name and the last name to be returned as one piece of data. So you can actually take two pieces of data and stick them together. They're just strings at this point, these pieces of data we're using. So there's a word for sticking strings together that we encountered when we were doing our JavaScript modules. Does anybody know what that word is?
Concat.
Yeah, concatenation is the full word. It's this word. That's the actual word, concatenation. Okay. So we can actually change what we're going to do here. We would actually like to concatenate, and inside the parentheses, you put the names of the two columns you want to stick together. So we want to concatenate first name and then last name. Now, this is a fake column. It's going to put these two things together and it'll be one column in our result set. I want to give that column we're making a name. We've covered in the last class or two the concept of aliases. Let's use an alias here, and we're going to call this actor name. Now, everybody, when you get caught up, go ahead and run it. This isn't going to be perfect, but I want you to see why it isn't perfect. Well, there's some good things. We've produced a result set that has one column and it has a name that we like. I like that, actor name. We can even call it actor full name. Let's do that. There we go, and run it again. It's an even better column name. We got a problem with this data. It literally just took the first and last name and stuck them together, and we can't read that now. Well, the way this concat works is you can put any number of strings inside it, and it will concatenate them. As an example, even though this is going to look really ugly, let's just put the actor ID in there. It's not going to be pretty. I just want to demonstrate that you can have 3 or 4 or 5 or many, many, many strings and stick them all together. Let's run that. Well, that's even less helpful, isn't it? And we don't really want actor ID. So what do we want? What would make this more readable? Go ahead and change it back, run it. What's going to make this more readable?
A space.
Yeah, just a space between them. Now, what's cool is inside the parentheses here for concatenate, you can specify whatever string you want. Obviously, we want to take the data that's in the tables and use it, but you can also just specify a string. That is an empty space, single character, a space, and another single character. Or sorry, quote, single quote, space, single quote. Now, when we run that, it takes 3 strings, the first name, a space, and the last name, and concatenates them. Now, that's a lot more readable. That's a nice friendly set of data to send back to a computer program, isn't it? Any questions about that? Now, let's experiment with some other formatting. I want these to all be lowercase. For whatever reason, maybe I'm communicating with millennials and they don't capitalize anything. Yes, I'm old. I want everything to be lowercase. Well, why don't I type lower, parentheses at the beginning of the concat, and then after the concat is over, and run it again. And look at that. I've shaped the data before I send it back to whatever program asked for it. Now, this is also another teaching moment. What we're doing right now is computing. I know it's very low level computing, but let's go back to the very first classes we had and talk about the purpose of a computer. Purpose of a computer is to take data in, to process it in some way, and then to output data. Well, we're having the computer where our database server is do our computing work for us. Why does that matter? Well, anything we ask it to do will take some finite amount of time. And you'll find yourself later on as you're putting together full stack programs, having to make some decisions about which computer is going to do a specific task. Do you have the database server, the computer that has the database server, do the work? Or do you just ship the data back to your application server, your backend server, and have it do the work? Or do you send it out to the client's browser and have it do the work? There's 3 places where computation can occur. Any questions about that? Okay. Let's look at another format. We have another, excuse me. We have another table that we have in here. It's the payment table. Now, we haven't looked at the payment table at all. So let's just look at everything in the payment table. Let's select star from payment. We haven't even examined this table. I'd like to see what's in there. Ooh, and look at this. There's a payment ID. Now, based on our conversation last week, what is this column called? It serves a special function for the table. What is the payment ID?
Primary key.
It is a primary key. More precisely, it is a key, which is a unique identifier for a row. And it is a primary key, meaning it is used to uniquely identify rows in this table. Let's look at the next column. This is a key as well. But it's not a key for any of the rows in this table. What kind of key is this and what's it used for? Someone besides Jonas, because I know Jonas, you just finished this module.
It's a foreign key.
It's a foreign key, exactly, Sudesh. What is it used for? What's its purpose?
To identify a row in another table.
Exactly, to identify a unique row in another table. Another way to think of it is to unambiguously define a row in another table. There can be no doubt about which row it points to. So let's move on to staff ID. What's going on there? What kind of column is this?
Also a foreign key.
Good. Now, without looking, do you have an idea of where it points to?
Could be a staff's name and staff too.
Exactly. Down in here, if we look at the columns, there's a staff ID, and that is a unique row with data about a specific staff member. Good. Excellent. All right. Same thing. What's this rental ID? Dana? Oh, you just answered one. Alexandra?
It's another foreign key,
Good. Pointing to what table?
the rental table.
Good. Excellent. Now, without looking, what kind of data do you think will be in a rental table? Without looking.
Probably like rental duration and rental rate and things like that you would need for when you're renting something?
You're probably close to right, but let's examine that one for a moment. Where have you seen rental duration and rental price already?
The film table, I believe it was.
Exactly. And this is yet another teaching moment. When you're organizing your tables in a relational database, and this is super, super important, never store the same exact data in multiple tables. If you've already stored rental duration and price in one location, do not store it in another location. You want to have one source of truth for the data. And since you're totally right, in the film table, we already know what its rate is and how long you can rent it for. But we do want to have that information for a rental. So why don't we just record what film was rented? And then if we need to look up the specific duration or rate, we can join the tables together. Does that make sense, Alexandra?
Yes.
Good. Then what else do you think might be in a rental table? We've got a film, so we know what film was rented. Do we know who rented it?
Oh yeah, so maybe like the customers that are renting it.
Good. But what piece of information are we going to store in there? Are we going to store their name?
Maybe, I'm not sure. I guess you'd store the name in the customer table. Yeah.
You store the ID.
Yeah.
Just point to the specific unique row that represents that customer. So here's the general concept is each row in a table represents a real tangible thing that you can walk up and touch and interact with. A customer is a real thing. A film, it's a real thing, right? And if you can point to the individual row that represents that thing, you can get any other information about the thing. So if you want to record events that occur in the physical universe, if they involve things like customers or films, just point to the customer and film. Don't record the customer and film information there. So let's open it up now that we've talked about it, and let's just look at this rental and look at some of the columns. Well, there's a primary key. There's a date that the rental occurred. We'll look at inventory ID in a moment, but look, we have a customer ID. One thing we don't have here that's kind of unique is what film. We don't have a film, do we? So what's going on there? Is there a column here that you did not expect to see? And that question is for anyone. We expect that there would be a primary key. We expect to have a date of the actual transaction, the rental transaction. We expect to know what customer did the rental. We expect a return date. That's not the same as a duration. Those all make sense. We even know what staff member was involved in the rental. What's this?
I
Anybody
think
got?
that's the critical
Go ahead.
point.
Tell me that again. I interrupted you. I'm sorry.
Okay, sorry. I guess the inventory ID is correlated with the film the customer rented.
Okay, good. Let's again. I'm going to ask you to anticipate what is in a table before we look at it, only because I want you guys to start thinking with the mental concepts behind how to create tables and their relationships. You can always look, but let's think about it a little bit first. Let's look at the concept of a film table. Let's pretend we're looking at the film Titanic. It'll have a unique ID. We know the title, Titanic. We know description, one of the best films ever made. We know when it came out. here's my question. Let's say it's 2005 and you're running this business called Sequila Video or whatever. How many copies of Titanic do you think you're going to have in a store? A lot, right? Is there anywhere in this film table that says how many copies of it we have?
No.
No, there is not.
And that's your clue to what the inventory table will be. It's going to tell what our inventory is. For a given film, how many do we own? So let's look at inventory. Look at that. There's a film. We know what store it's at. Let's even look at all of them. Open up a new tab here, and let's just, let's see, Sudesh, give me the syntax if I want to look at all of the records in this inventory table.
Use Sequila. Select star asterisk.
Yeah, star is good.
Yeah, and from inventory.
So let's explore this a little bit. The first column. Dana, what is that first column?
Going to be the inventory ID.
Yeah, what's the purpose of that column? Why is that data there?
To label which rental it is out of the number of rentals.
Okay, I think we're on the right track. It is, if a row represents one thing, we need a unique identifier for a row. What each row represents here is an actual physical tape of a specific movie in a specific store. So these middle pieces of data are what film is it and where is it? And because we entered that data into the table, at the time we entered the data in, we need to assign a specific unique identifier for the row. This inventory ID doesn't identify what the film is. It just says, hey, in my inventory table, I made an entry. Here's a unique number for that entry. That entry happens to be concerned with film number 1 that's in store number 1. And the clue to how all this works is on the very next line. This is the exact same film number 1. It's in the exact same store number 1, but we've given it its own entry in the database. Why? And that why is for anyone who wants to answer.
Because it's a brand new record at a different time.
It is a brand new record, you're right. What is it meant to reflect in the physical world? Why did we enter that second record into the table?
Maybe a different copy.
It's a different copy. That's exactly right, Dana. It's a second tape. It's the exact same movie, but it's a second tape. So we make a second entry. Now, what this tells you is that the philosophy behind this table is the quantity of a specific film is calculated by the same film ID repeated how many times. Here we have 8 copies of Titanic. If let's just pretend number 1 is Titanic. We know it isn't. Let's pretend this represents the movie Titanic. We have 8 copies. 4 of them appear to be in store number 1, and 4 of them are in store number 2. There's a different way to do it. You could have a single row that has another column called quantity. You could do it that way, and you could change the quantity every single time. But we, the people that designed this database, we wanted to be able to specify an exact physical tape. If you had only a single row with film ID of 1 in store 1, and another one with film ID of 1 in store number 2, if you only used separate rows for that, we could have a quantity in yet another column, but when it changes, we don't know what physical tape actually went out the door. We don't know which physical object we gave to the customer. And in the way we operate our business, we want to know that information. And these are all things you'll have to think about as you design databases. Now, you probably won't be designing databases when you first start, but you will be doing what we're doing here, and I've done in the previous classes. You'll be exploring the structure of the database and trying to figure out the philosophy behind it, the thought process involved. When do we enter in a new row? When do we change the data in that row? When do we delete a row? You're going to want to understand the philosophy behind it. So here's my question for this table. When would we add a row to this table?
When there's a new copy.
Yeah, one of the stores gets a new copy of a movie. That's when we add it. When would you change the data in one of these rows?
Upon when a customer rents a
Would
video.
that change the name of the film or the store that it's registered to?
No, but we would have to indicate that it has been out.
Right. Does this table store information related to whether or not a specific copy has left the building?
No.
Okay. So I ask again, can anyone think of a circumstance under which we would change the data in one of these rows?
When a copy is lost.
There you go. You wouldn't actually change, you'd only add or delete a row. Sudesh was on the right track. If we lose this 4th copy of Titanic because someone's kid poured orange juice on it or whatever, then we would remove it from the inventory table. And when a replacement came, because we would charge the customer, we'd enter in a new row to represent that because it's a different physical object. Now, again, it may seem like we're buried in the weeds on this kind of stuff, but we're learning a number of aspects of databases. First, yes, we're learning SQL, the actual language itself. But of almost greater importance, we're learning some of the principles behind why would you divide data into tables? How would you define the relationship between them? And how would you interact with the table based on what occurs in your business activity? This one's pretty straightforward. It only records the fact that we purchased a movie and assigned it to a store, or that a movie was taken out of commission. That's all this table is used for. It's not recording events in the real world. It's recording objects we own. Now we're going to do things with these objects. We're going to rent them. That goes in another table. In fact, it goes in the rental table. And now these columns will make a little more sense. Yes, the rental ID is a primary key, but what we're recording is when did the rental take place? Which exact cassette did we rent? Notice we don't need to record the movie. Why? Because that's over here in the inventory table. We can find out what movie. But we record which cassette we gave them. We record who did we give it to? When is it due back? And which staff member did the rental? This table, this rental table, is transactional in nature. It records transactions that occurred in the physical universe. Other tables, like the inventory one, will record objects, things. So yet another way to think with, why do you make a table? What would a table come into existence for? Is it to record physical things like customers or employees or office locations? Or will it record events like the rental of a movie or like pay changes for employees or orders made by a customer? Like, you have to think about what data, what kind of data goes in the table. All right, good. So we started all that by saying, okay, what do we think would be in, let's collect staff in a rental table? And we got most of it. We found this inventory ID and went, wait, what the heck is that? And that's when we realized a film table will just record a film in the abstract, the idea of a specific film, like Titanic or Star Wars. We need an inventory table to record how many of a specific film we have and where is that actual cassette. Any questions so far? All right, let's go back to our original tab. So to get back to this, we were looking at this payment table. We already figured out that each row, this is a transactional table. This doesn't record physical things. It records events. The event that it's recording is a payment occurred. Okay, let's assign a unique identifier to the event. This is the payment ID. What customer was involved? What staff member was involved? And what rental occurred? The rental, as we saw, tells us when did they do it? What exact cassette did they get? Who are they? When is it due back? And what staff member was involved? Notice that a different staff member can take the payment than did the rental. We do record the amount here. Now, the amount of the rental exists somewhere else. If we look at rental ID of 76, I want to look at rental ID of 76. Let's open a new tab, and I want everyone to see what's in rental 76. How do I get 76's data?
By writing the where clause.
A where clause. What's the name of the column that I'm going to match?
I think it's inventory ID.
It's rental ID right here.
Rental ID, sorry.
Yep, that's fine. Run that, and all you need to equals 76. There we go. All right. So this is the date it occurred in 2005. Look at that. Inventory ID of 3021. That tells us what film. I'm trying to figure out the cost. All right, well, let's do another selection. You can do multiple selects. Select star from, let's see, inventory. where inventory ID. Oh, I need a semicolon at the end of line 6. That's why it's giving me a red warning. 3021. All right. Give everybody a chance to get caught up. We're going to get 2 result sets. The first query and the second query. So run this. We have 2 results down here. Oh, I highlighted it. Yeah, we have 2 results. You have this first one from the rental table. And we were curious about inventory number 3021. That's right here. Oh, so we rented film number 663. All right, how much does that cost? Let's do a third query. Uh, 663. What film is this? Now I've got 3 tabs. Well, it's called Patient Sister, and it costs 99 cents. Interesting. Well, let's go back and see if this makes sense to us. So, oh, that was a mistake. What we're saying here is a payment occurred. Someone paid $2.99. The rental table stores an event. That event is rental number 76. We're numbering our rentals. So we went in here and said, okay, rental 76. When it happened, we changed the inventory, or we recorded which item in our inventory got rented. It was item number 3021. And down here, item number 3021 is a physical copy of film 663. It's in store 2. And film 663 is called Patient Sister. And it only costs 99 cents. That's weird, isn't it? Isn't that weird? Don't you think they would have paid 99 cents? Does anybody see the problem? All right, so let's have a little fun here. I just did something really clunky here where I had to manually trace down if I have a rental number 76, how much did it cost? Well, how much did that movie cost? I had to plug all this stuff in and make 3 queries, all because for my payment table, I wanted to figure out how much did the movie actually cost? Well, instead of 3 or 4 queries, how could I get all that information with 1 query? Any thoughts? Notice there's a connection between all these tables. This payment table that we're looking at right now connects to the rental table, doesn't it?
Yes.
And the rental table connects to the inventory table. And the inventory table connects to the film table. Well, let's join them, shall we? Let's make a big join. All right, so I'm going to go through this slowly, and I'm going to build it the way I would actually build it in real life. what I would do is first successfully join the tables and only then specify the columns that I wanted to read out of each table. That's what I would do. So I would do a select star. I'd actually put the star on this line here. Now I'm going to go from payment to rental to inventory to film. I'm actually going to make a comment in here. 2 dashes. Payment to rental to inventory to film. Just to remind myself what I'm doing. You guys should make that comment too. And let's just think through this. So the first thing is the payment table. And I want to join to the rental table. What column do I want to join on? In the payment table, what's the name of the column? That I want to match in the rental table.
Rental ID.
Absolutely. So the rental column typo there. All right, now I want to join. Now I've joined payment to rental. I need to go from rental to inventory. What column in the inventory? Actually, in the rental table, what column do I want to match on?
Rental ID.
Nope. How do I get from the rental table to the inventory table? Well, let's look at rental table. Here's some rental table results.
Rental ID.
But I'm in that table. I want to get over to inventory. So let's look at the inventory table. Inventory table doesn't have a rental ID.
Inventory ID. Yeah.
Yeah, we'll move to the inventory ID. So if I've got in the rental table, look, this is the rental table right here. Okay. I have an inventory ID. It's a foreign key pointing to the inventory table. This column is not a primary key. The primary key is over here. This is a foreign key pointing to the inventory table. So I want to do my inventory and I want to match it on what in the inventory table?
Inventory ID. Yeah.
Absolutely. So I've gone from payment to rental, from rental to inventory. Now I need to go from inventory down to film. So I'm going from inventory to film. What column in the inventory table will I try to match over in the film table? Alexandra?
The film ID.
Absolutely. And finally, I want to specify what payment am I trying to get all this information for? I need a where clause. Now, what payment do I need? If I look at my payment table, it's payment ID of 1. The very first one, that's what I want to look at. So here I am. Let's run this. We're going to start at the payment table. And we're going to get all of this data that's already in row number 1. And then we're jumping to the rental table. We're going to get all this data that's in row number 76 in the rental table. When we jump to the inventory table, we're going to get all this data that's in row 3021 of the inventory table. And when we jump to the film table, we're going to get all this information that's in row 663. We're going to get a lot of columns. Go ahead and run it. And wow, did we get a lot of columns? We got everything that's in the payment table. And then everything that's in the rental table for row 76. And then everything that's in the inventory table right here for row 3021. And then everything in the film table for row 663. We got everything. That's a lot of data. Not a very friendly result set, though. What I'd like to know is how much was paid, what was the name of the movie, and how much is the rental rate. So where do I find out how much was paid? What table?
Payment table.
Payment table, exactly. So in here, we'll go payment dot, and then it's amount. Now, where do I get the name of the movie?
I think in the film's ID.
It's in the film table. Where do I get the name?
Film ID.
Film ID is a number.
Okay.
What's the name of the movie? What column in this table?
Title.
Exactly. And then where do I find out how much it costs to rent that movie? What table? If you this question is say again.
I think it's in the rental.
In the what?
Rental table.
In the rental table? Let's look. Let's look where rental begins. Rental begins right here.
It's not here. Okay.
Yep. We have the rental date, the inventory, the customer, the return date, the staff, and the last update column. There's nothing about how much it costs. Where's information about the daily or about the how much you charge to rent a movie? Let's look at inventory. It's not there. Records what film, what store it was at. Look at the film table beginning right here, film number 663. And there it is. The rental rate is right inside the film table. So we do film. So now let's run this again. They paid $299. This is the film they rented. And this is the rental rate. Now, I don't know about you, but that doesn't make sense. We're going to explore why that would be. Because remember, you're trying to figure out how this database works because you need to build programs that will work against or work with this database. Now, you could always ask another engineer on your team. But let's see if we can figure it out. So, does anybody have any thoughts on how we could try to figure out what the relationship here is?
Having a flow diagram.
Say again?
Having a flow diagram.
A flow diagram's good. Okay. We picked one movie. I'm trying to observe patterns here. What if we looked at a bunch of payments? Why don't we go down and comment out our where clause? So we're going to get every single row that's generated. Let's run that. Ooh, now we got a lot more data. Well, look at this. Academy Dinosaur has a consistent rental rate, but the amount that gets paid changes. It's all over the map. Maybe there's something about how the payment table works that we're not sure about. Let's look and see if somewhere in these 4 tables, there's information that can help us out a bit more. For example, in the rental table, we have a rental date and a return date. Do we know for sure how long each customer had the movie? We don't right now, do we? How can we figure out how long they had the movie?
Difference between rental date and return date.
Yeah, since we built this join, now we can start looking at even more data. So let's go to the rental table and look at the rental date. Oh, I didn't do a column, a comma. And then let's also look at the return date. Run that. Well, this is kind of hard to read. They rented it on July 8th, returned it on July 11th. Rented it on the 2nd. Oh, look, they returned it on the 11th. That's 9 days. You know what would be a lot easier is if I could see the difference between these more easily. I've got to go through and just calculate how long this was, don't I?
Yeah.
Well, let's see if we can figure that out. I have 2 dates. Can I figure out the difference between them? Here's our good friend Google. Let's go SQL difference between, second query, difference between 2 dates. Hello, Google? Hello, Google? All right. Ooh, look at that from W3 Schools. You have a date diff function. Return the difference between 2 date values in years. That's not helpful. I don't want year. I want it in days. Oh, look at that. You can do year. You can do day. Oh, well, let's copy this and see if we can figure something out like that. I'm going to copy it up here as a comment and just start working with that. So I want to select the date difference. And I want day And then the two dates that I have. What's the later date? The return date is later. So let's do rental dot return date. And then rental dot rental date. And we need to give it an alias. They're calling it date diff. I like date diff. That's excellent. Give you guys a second to catch up. And let's see if this works. Got an error. Incorrect parameter count in the call to date diff. All right, so it needs more parameters. Let's look back at the syntax and see if I got something wrong. Date diff. Here's the part, one date, and then two dates. Here's the part, one date, two dates. Incorrect parameter count. All right, let's see if there's more here. Interval, date one, date two. You know what I noticed? You know, month, hour. Incorrect parameter count. Let's see if it'll give us, let's try to retype it again. It's interesting. It's got parentheses after it. I wonder if for some reason it needs parentheses. Through an error. Oh, that error is not from me. It's something else. Oh, a semicolon at the end. Nope. It's mad about something. All right, let's comment this out and make our, this is another important lesson. I'm trying to do a really complex syntax and I have an error in syntax.
How about, sorry, how about the comma?
Hold on a second, Jonas.
Okay,
You're probably right. Okay, but I just want to take this as a teaching moment. Okay. I'm trying to do a really complex kind of query and I'm throwing a syntax error. I want to remove the weird work I'm doing and see if I still have the error. I do. So it's got nothing to do with what's inside here. And he's right. I have a comma here, like it's expecting another column. And then makes it go away. All right. So now if I do this, uncomment this, and take away that comma. All right, let's try it. Still incorrect parameter count. But now let's try that day as a function. Because it was trying to tell us that, I think. Nope, doesn't like that at all. All right. When I look at this example, I think we've got it correct. Return date and rental date are both dates. And the error we're getting is incorrect parameter count. All right, well, let's Google that. Incorrect parameter count, date diff. So SQL error, incorrect parameter count, date diff. Let's try this first one from Stack Overflow. I get the error from this line. Date diff. They're saying check the difference and see if it's less than 30. They have the same thing, day, a start date and an end date. Oh. MariaDB is another database engine. That's not what we wanted. I want MySQL. Then let me put MySQL error. MySQL error, incorrect parameter count on date diff. Hello, this is my first time using date diff and it looks pretty straightforward. By the way, what we're encountering here is most likely a slight difference in syntax between database management systems. MySQL may do it slightly differently in terms of implementing date diff than, say, SQL Server from Microsoft. But let's just look. My first time using date diff looks pretty straightforward. My goal in the code is to get all records more than 30 days old. Select everything from this schedule. Oh, DD for day. Timestamp, current timestamp. Oh, let's look at the manual. You do have the wrong parameter count. Date and time functions. Date diff. Returns expression 1 minus expression 2. Expressed. Oh, we don't have to put the day. Look at that. And I think we have a bit of our clue here. Notice the pattern. The longer rentals, they're paying more. What's the piece of data we're missing here? I just spotted it. I wonder if anybody else has.
Would it be the rental duration?
Yes, Alexandra. So let's, right after the rate, what table is the rental duration stored in?
The film table.
Put that in, run it. So Academy Dinosaur costs 99 cents and you get it for 6 days. These people had it for 3 days and only paid 99 cents. These people had it for 9 days, paid $3.99. 7 days, they paid $1.99. So there's some sort of graduated pricing structure here based on how many days. Do you see how we're just starting to get more and more insight into how things run? Now, if you came to work at this company as a software developer, they might also have a set of like operating manuals for the software that would tell you these business rules. These are called business rules. It's the logic that the business operates on that we need to implement in our electronic systems, in our computer programs. We could just as easily do with this with pen and paper or Excel, but we're using computer programs to do it. So I just kind of want to show you the reason I went through this whole exercise is, one, to just gain a little more experience in joining tables together. But two, to show you that given a little bit of time to just peek around in a database on your own, you can start to learn a lot about how the database works and about how the database is used by other computer programs. Kind of interesting stuff. And along the way, we got to make a pretty complex join where we joined 4 tables. The payment that happens at the end when the client comes back, joined to the rental table, which records what occurred when they left the store with the movie, to the inventory table that records which actual physical cassette they left with and what store they took it from, back to the film that records data about what was on that cassette. And because we joined all 4 of those, we can start to get a lot of valuable data starting from the beginning. What movie did they rent? All the way through, we could figure out which physical cassette was it, because we have that in the inventory table, and we know how much they paid. We could even join to the customer table and get the name of the customer if we wanted to. All right. So a little bit of homework. The first homework is I want you to actually figure out how to display what customer rented the movie. Change these joins here. Change this complex SQL we built to show what customer rented the movie. So that's the first homework, okay? The second one is this. I found a pretty good set of practice exercises to do on the Sequila database. I'm going to pull it onto the screen so that in the future, anybody watching this on video can see where to get it. There's the URL. It's on the screen. Now I'm going to put it inside Discord as well. Let me copy that. And I just want you to go through this as far as you can get in the next 2 days. That's all. Doesn't matter how far. If you can get down to where we're doing joins, that's great. And especially the aggregate functions. I'd like you to get that far, but it's 2 days. Everybody's got different availability. All right. I think we're going to end off with about 5 minutes to spare. Does anybody have any outstanding questions from what we've been going through here in these exercises? One piece of homework that I gave last week, I'm going to give this homework again. I'd like you to try to build this join, this 4-table join on your own without looking. Just with this comment right here. Join from payment to rental to inventory to file to film. With that comment, try to build this join again without looking. That's in addition to trying to modify this so it shows customer information. Any questions from anybody? Okay, cool. Now, there's a lot going on in databases. And I'm going through this. If I'm going too fast, and if when you're trying to do some of this homework, you're like, man, this is kicking my butt. Reach out to me. I'll do whatever it takes to get you through this stuff. If we need to schedule a one-on-one kind of Zoom call, we will, okay? This stuff is vital. It's vital stuff. and it can all be learned. But if I'm going too fast or if I miss something, if you're not grasping it, I want to know right away. Okay. All right, cool. That's what we have for the evening. It's Thursday. I will see you all again. Oh, I'm taking Labor Day off. For those of you who aren't in America, that means nothing. But next Monday, I won't be available. And we're gone through Wednesday. So our next class is actually going to be 1 week from now on Thursday. So I'm going to amend that homework. I'd like you to get all the way through those practice things from that Sakila article that I just sent you from Corey Clip, who put together a really decent set. I am, of course, always watching my phone and on Discord. So the same thing flies. If you need help, reach out for it. I will make the time for you. Okay.
Thank you.
And yeah, absolutely. For those of you in America, enjoy your Labor Day. Sheree and I are going to go take our pop-up tent and go up to a lake up near Mount Rainier, which is near Seattle, and just relax by the side of a mountain or a lake and just connect for a couple of days. Be very, very cool. So
Is the weather still good?
yeah, the weather's fantastic. The weather's really good. Yeah, like today, 88 Fahrenheit. I don't know what that means in Celsius, like 27 or something like that.
Yeah.
Yeah. Yeah. It's been pretty nice here. Anybody have any plans for Labor Day?
No.
Okay. Do something, treat yourself. I'm really glad you're here, Dana. Filling up the class, participating is great. It's good to see everybody all in class at once. And if you have anybody that you think would be good to fill out the 5, let me know. I'm also reaching out on a couple of things. I don't yet want to put an open call on Twitter for it yet. I'd rather try to find it from within our group if we can first. So, all right. Thanks all. Have a great evening. It's good seeing you.
Okay.
Thank
Thank
you.
Good
you.
night.
Bye.
Everyone.
Bye.